Assalamu alaikum wa rahmatullahi wa barakatuh. I am Mr. Walid. I'm a teacher of maths for secondary stage. Welcome back, my dear students. In secondary stage, we are going to complete our chapter 1 in algebra, which is functions of real variables. Today we have a very important topic related to the same chapter, which is functions, linear function. How can we graph the linear function? We have to remember that the linear function is represented by a straight line or a ray or a line segment, that's which is related to our domain. Now let's see. The question will be, draw the graph of the following functions, and from the graph we have to find the range and discuss its monotony and also determine its type, with whether it's even or odd or otherwise. Let's see example number 1. Now we have a function as x squared minus 9 over x minus 3. This is a fractional function. First we have to determine its domain. Now we remember that x minus 3, the denominator must not equal to 0. So our domain will be R, all real numbers different 3. But after we factorize the numerator by using difference between two squares, we can cancel the common factor up and down. So here the resulting function after simplification is x plus 3, but with the same domain, which is R difference 3. Now this domain and this function are represented by a straight line, but at 3 we will have a gap, we will have a circle, because 3 doesn't belong to our domain. Now let's see the graph. First point, we can replace x with any point in the real number except 3. So if we replace x, if we substitute x by 0, the image will be 3. So the first point, 0 and 3. What if we substitute x by 3, which is 3 is not accepted. But here if we substitute x by 3, the image will be 6, which we have to remove from our range. So if we replace x by 3, which is not accepted, which is not belong to our domain, the range will remove 6 from our range, which is now the last point. Replace x with negative 3, we will get negative 3 and 0. So here we have 3 points non-collinear, but in front of 3 we have a gap, because 3 doesn't belong to the domain and also 6 doesn't belong to the range. Now the straight line will be as it is, and don't forget this gap means that 3 doesn't belong to the domain and 6 doesn't belong to the range. Now the type of the function, it's neither even nor odd, because it's not symmetric about the y-axis, and also it's not symmetric about the origin point. The range, all real numbers are the range of this function except 6. So the range will be all real numbers except 6. Now this function as a behavior, it's increasing on its domain. So the function f of x is increasing on R different 3. Let's see another example. Now we have a linear function defined by two different rules, but we have here 0 as a boundary point between these two rules. The first rule is starting from negative 3 and ending with 0, so it's represented by a linear function but as a line segment, because we have a starting and ending. Let's see how can we graph. Now the domain will be all real numbers starting from negative 3 to 2, because we state the domain of the whole function. Now the first, if we replace x by negative 3, here Negative 3 plus 1, it will be negative 2. So negative 3 and negative 2, the first point. And if we replace x by 0, it will be 0 and 1. But here, open, because 0 not equal x less than 0 and not equal. So 0 doesn't belong to the first interval of this function. The second definition, the second rule of this function is 3x. We have to replace by 0. It will be 0 and 0, the first point. And if we replace x by 2, it will be 2 and 6. Here, the last point. And we have to join them to get two line segments. The first two for the first rule, and the second for the second rule. Now, let's see that 0 has only one image, which is 0 and 0, which belongs to the second rule of the function. But in the first rule, 0 here doesn't belong to the first interval, so we have to put open circle to indicate that 0 doesn't belong to this function, or doesn't belong to the first rule of the function. Now, the type of this function is neither even nor odd, because it's not symmetric about the origin or the y-axis, and also the range, the minimum point of the function in front of negative 2, and the maximum point in front of 6, so the range will be negative 2 and 6. Here, the function increasing in the first interval from negative 3 to 0, as we see that the function, when we move on the x-axis from the left direction to the right direction, we will see that the graph is increasing. And also in the second part of the function, when we move from 1 to when we move from 0 to 3, the function also is increasing. Now, in the two parts, as we said, the two parts of the function are increasing. Let's see another example. Now, we have a function defined by three different rules. And the boundary point here, negative 2 and 2. Let's start with the constant part. Now, we can deduce that the domain is all real numbers, because x here, in the first part, all real number less than negative 2. And in the third part, all real number greater than 2. And also we have taken all real numbers between negative 2 and 2. Also, negative 2 and 2 belongs, because here equal sign, x greater than or equal and x less than or equal, so which refers that negative 2 and 2 belongs to our function. Let's draw the constant part, which is 3, represented by a line segment parallel to the x-axis, starting from negative 2 and ending with 2. Here we have the first line segment. Now let's start with x plus 5. If we replace x by negative 2, negative 2 plus 5, it will be negative 3. So this point will be the starting point of this ray, because the first part represented by a ray with a starting point negative 2. Here, as we said, that the same point when we replace x by negative 2, and we have to replace x by any number less than negative 2, such as negative 3. If we replace x by negative 3 to get the point which gives us the direction of this ray, it will be 2. So if we replace, by the way, negative 5 plus 5, 0. So this point, negative 5 and 0, indicates the direction. If we start drawing the ray from this point to the other one, we will get the ray which refers to the direction of this part. Now let's start with the third one. If we replace x by 2, 5 minus 2, 3, which gives the same point. So this point also is the starting point of the other ray, and we can replace x by any number greater than 2, such as 3, 4, 5, and so on. So if we replace x by 5, we will get 5 and 0, and this point indicates the direction of the last ray representing the third part of the function, and so the ray will be as it is. As we see that this function is symmetric about the y-axis, so the function is even. Now, let's discuss the range. The maximum point of this function in front of 3 on the y-axis, and it's extended down, so the range will be from negative infinity up to 3. Now, f of x is increasing in the first part from negative infinity up to negative 2, and from negative 2 to 2, the second part will be constant, and the third one will be decreasing part starting from 2 up to infinity. Now, I hope that our lesson was very easy and successful for all of you. Thank you very much. Hope that I can see you very soon, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.